Alright, the integral inverse sine x dx. So let's think about this. How are we going to do this? How are we going to evaluate the integral? So let's see here. We're staring at the problem, right? We're taking a good look at it, and it looks like there's nothing to substitute out, right? Because if you want to substitute something, we should probably have its function and its derivative somewhere. Right now we have an inverse sine x, so we don't have its derivative. And it looks like we're cooked. So next thing we try integration by parts. So you're thinking, right? So integration by parts, we need something to integrate, we need something to differentiate, right? Well, we don't know the integral of inverse sine x, that's what we're trying to figure out. But we know how to differentiate it. So if we differentiate inverse sine x, well, what are we integrating? Alright, see, this is where you pull an interesting trick. So you say integral of inverse sine x dx is equal to integral of 1, right? 1 times inverse sine x dx, right? This is something we can differentiate. 1 though, 1 is something that we can integrate. So let's see, we pull out the quick u is equal to inverse sine x, right? We can differentiate that. And we get that du is equal to 1 over square root of 1 minus x squared dx, right? Standard derivative. We know that dv is equal to 1 dx, so this dx. We get that v is equal to x. Alright, so let's just use the old integration by parts formula to see what we get. So let's see here, integration by parts, uv, so x inverse sine x, uv minus the integral of v, so v du. Alright, so v times du. So minus the integral of x over the square root of 1 minus x squared dx. Alright, so this is our next task, integrating that. Now let's see here. Now let's take a good look at this integral right here. So I'm staring at this, right? I'm getting a good look. Let's see, can we substitute anything out? Well, let's see. I see a 1 minus x squared. This looks interesting. Because if we take the derivative of that, we get minus 2x, right? Minus 2x is basically just, okay, in calculus line, minus 2x are basically the same thing. We can do some modifications. So we can do a good substitution on this one. So we'll say that I already used u. I'm gonna use w because w is kind of cool. So I'm gonna say w is equal to 1 minus x squared. So dw is equal to minus 2x dx, which means minus 1/2 dw is equal to x dx. This is terrible. X dx. Hopefully you can see this. I'm actually running out of words, but that's actually so tragic. X dx. Alright. Whatever. Okay, so let's see here. We'll move over here real quick. So we're gonna have x inverse sine x minus. Alright. So think about this. We're gonna have the integral, right? This 1 minus x squared got replaced with a w, right? And so we have x over root w. We know that x dx is equal to negative 1/2 dw. So we can actually replace this, get rid of this x, with a minus 1/2 dw, right? So do we see how that happened? X dx, and this x dx got replaced with a minus 1/2 dw, right? So, well, yeah, we just replaced it. So bring this negative 1/2 out here. So you get x inverse sine x plus 1/2 integral of 1 over root w. I'm just going to rewrite as w to the minus 1/2 dw. Alright, use the power rule on that one. And then for a final answer, we get x inverse sine x plus 1/2. Let's think about this. Add 1 to the exponents. Let's see, negative 1/2 plus 1, that's 1/2. And then we divide by the new exponent. So we have w to the 1/2 divided by 1/2. And that gives us x inverse sine x. Alright, so what's this going to do? 1/2 and this 1/2 down here are going to cancel. So we get so x inverse sine x plus root w, but w is 1 minus x squared. So x sine x plus root 1 minus x squared plus c. And that is our final answer. So integrated by parts, they said it couldn't be done, but we did it, so we made up a 1 right here. So interesting little trick. If it looks like life is failing you, integration by parts is not going to work. It might just work if you just use a 1. So top 10 calc tips of all time. I'll see you in the next video.